Hi, I'm Shawn Jones, Process and Development Manager here at Arkion Life Sciences and co-author of the poster Measuring IgG and Specificity in Milk Replacers, along with Roger Saltman and Michelle Tolfson. Thank you for your interest in our poster. I'm going to walk you through some of the key findings now. So first, what was the motivation behind this study? It actually came from a conversation with a field vet a few years ago at a trade show, where he was talking about a calf ranch he was overseeing that kept getting this rotavirus outbreak. When he would communicate this with his home office trying to figure out solutions, they said, the milk replacer has antibodies in there to deal with it, so it shouldn't really be a problem. Also, he was frustrated because the antibodies weren't taking care of it and the calves were getting sick. And so after this conversation, Roger, Michelle, and I were talking, and we were wondering, is there a way we can measure the specificity of these antibodies in the milk replacer? And the result is this study, yes, where we found that we can measure the specificity of these antibodies, and the result is this work here. So we ended up doing was taking 5 commercial calf milk replacers and measuring them for their total amount of IgG and also their specificity of the IgG, particularly for pathogens that cause scours in calves. So these are the 5 milk replacers that we chose. These are milk component only milk replacers, so these don't contain any bovine plasma in them. As you can see, they're all named brands: Milk Specialties, TFA, Dankovic, Lana Lakes, and Provimi. Now, importantly, the milk replacers listed here, we randomized all these samples so that how the results are presented in the poster itself are not in this order. Our goal was to analyze the milk replacers, not really call out a specific company, but just really kind of look at them in general and kind of what trends we see overall. So the first thing we did was measure the total amount of IgG in each of the milk replacers. So here the amount of total IgG in samples A through E. So again, the sample A through E has no correlation to the previous table that showed, but they are the same. It's all the same 5 milk replacers, just the order is not the same. So as you can see, there's actually quite a range of IgG concentrations. The highest was at 12.2 in sample E, down to 2 milligrams per gram in sample B. So a decent range, going from over 10 milligrams per gram in 2 samples to 2 in the lowest sample. So next thing we did was look at the specificity of the antibodies. And how this was done was, first we took the milk replacer, reconstituted it according to the manufacturer's instructions. We then decreased the pH to cause the casein to crash out. We then took that supernate and applied ammonium sulfate precipitant to that to cause the IgG to precipitate out. We then took that precipitate, cleaned it up a bit more through a protein A column, and then finally dialysized against PBS to get a purified IgG from the milk replacer. We then took that purified IgG and then labeled it with a peroxidase as a reporter enzyme, and then we did direct ELISAs with different antigens of interest, and we measured the output of the A450 value. Now, for those of you not familiar with ELISA, this is how it was performed. So again, these are direct ELISAs. So we took our antigen of interest, whether it's bacteria, a virus, or a specific antigen of interest. This is absorbed onto the surface of a 96-well plate. We then wash the surface, so any unbound antigen is washed off, and only the bound antigen is left. We then apply our antibody solution that has been labeled with the peroxidase to this plate. If the antibody has specificity for the antigen, it's going to bind to the antigen and stay bound. If it doesn't have specificity for the antigen, it's not going to bound, and it'll be washed away when we do our wash. So the final step is we have our antigen along with our bound antibody onto the plate. We then add a substrate to the plate that interacts with the peroxidase to actually change color. So it goes from this kind of bluish color to this yellow color. And this yellow color is the output of the assay. This is the A450 measurement reported here. So it's really a measure of how much bound antibody is on the plate. The more bound antibody you have, the more this reaction takes place, so the more reactive substrate you have. So the higher the A450 value, the higher the more bound antibody you have on the plate, which then will lead to more binding within the calf and hopefully a decreased disease incidence in the calf. So again, higher A450 means more antibody, means higher protection for your calf. And then these are the 9 antigens we looked at. Again, so all causes of scours: rotavirus, coronavirus, crypto, E. coli, 3 different salmonellas, and 3 different perfringens, type A, C, and D. So here are the specificity results. Now, first, how was this done is all the milk replacers were analyzed on a dose of milk replacer, and we consider a dose was a 10-ounce measurement of the milk replacer was considered a dose, and then the amount of IgG. So we know the volume of the milk replacer that we want to test for. We know the total amount of IgG in that mass of milk replacer. So the amount of IgG we loaded onto the plate was equivalent to that mass of milk replacer that we're testing. And all the milk replacers were tested under a 10-ounce dose. This isn't necessarily the recommended dose for all the milk replacers, but we chose this as a baseline to compare them all. So here you can see samples, again, A through E, and the different specificities to the 9 antigens we tested. So I'm going to bring back up the total IgG and to make some interesting observations that we saw. So first, looking at sample E, this had the highest IgG concentration, and look at the graph here, this also has the highest specificity across all antigens. Sample B had the lowest IgG, and unsurprisingly, sample B had the lowest specificity among all the samples. So for right now, we see that the highest IgG matches with the highest specificity, and the lowest IgG matches with the lowest specificity. But kind of in between, it gets a little more complicated. So sample A, based on the total IgG, looks comparable to sample E. But if we look at the specificity, sample A is actually much more comparable to sample D. It's significantly lower than sample E. And sample D almost has about half of the amount of IgG. So sample A does have a lot more IgG, but doesn't really offer any more specific protection than sample D. If we look at sample B and C, C almost has about double the amount of IgG, but its specificity is still pretty low. So it's really important to look at both the total amount of IgG you have, but also the specificity. Just by having a lot of antibody doesn't necessarily mean you have the right antibody for the protection that you want for your calf. So what we saw from this analysis was there was quite a bit of wide variation between milk replacers, both in terms of their total amount of IgG and also on the specificity of that IgG. And that just having a high IgG doesn't necessarily mean you have high titers for specific IgG. You also need to measure for the specificity of the IgG to make sure it does have it does cover the pathogens you want it to cover. And so we really see a need to test both the total amount of IgG and the specificity to really get an idea of how much these milk replacers offer protection for your calf. Now, one thing that came out of this analysis is as we're showing these results to some customers and some suppliers, we did find there was a need. There does appear to be desire for a testing service in the industry. So we are looking to offer this service through our partner BTR in Manitowoc, Wisconsin. So BTR is a division within Arkion Life Sciences, but they are a contract research organization. So they're used to working with customers and keeping results confidential. Typically, BTR does fermentation and strain development, but they also offer a range of analytical services, and this would be under their analytical services offering. So you could submit different types, either a milk replacer sample, a colostrum sample. Let's say you're an ingredient manufacturer and want to submit your whey protein concentrate. So different samples you could submit and looking at different specificities. Again, all primarily focused on scours. So E. coli, salmonella, cryptosporidium, also looking at coronavirus and rotavirus as well. We're hoping to launch this by Q3 of 2024. We're still in the works of getting all the assays figured out and how all the SOPs nailed down. But if you're interested in this service, definitely reach out to us and we'll keep you updated as we progress towards launching the service later this year, hopefully. Thank you for your time and your attention. For more questions, please visit our website. And again, happy to answer any questions you have. Thank you. Bye.